We are going to finish talking about sitemaps and sitemap XML. And then we're going to start talking about database design. I think we have a little bit more to go about sitemaps. One of my goals in talking about the sitemap file is not just to talk about the specific sitemap file, but to talk about XML in general. And remember, the ML in XML is markup language. So what that means is that you use tags to convey what certain information means. And tags in XML are very similar to tags in HTML. HTML is sort of a subset, subset with a couple of rule changes of XML. They sort of came from the same source, a language called SGML. The X in XML stands for extensible. I don't know why it's not EML then. I don't know, the X seemed cooler, probably, at the time. More catchy. You know, get people thinking of the X Games and all that kind of stuff. So I don't know, but it's XML. And extensible simply means that you can create your own formats. It's flexible, and you can create your own formats for any sort of data exchange. And people can create their own languages, and the languages follow a certain grammar. They follow a certain set of rules. In other words, a starting tag has an ending tag. That's a rule of XML. All tags are lowercase in XML. All attributes are enclosed in quotes. Tags are nested, have to be nested in a certain way, and all that. And the advantage is then you can have some generic software that understands XML that can parse that and help you. Whereas if you use other data exchange formats, like a flat file, the work is all on you to figure out how to take that and put it in a meaningful form. Where with XML, you can, if the file is, or the data is guaranteed to be in a certain format, you can have classes that assist you in reading it and handling it. So that's sort of the idea behind XML. All right, is that it's extensible. Now, extensible doesn't mean that anything goes, as far as taking a predefined format and extending it. In other words, I can't just make up tags and put them in my sitemap file, right? I have to follow the rules of the people that created the sitemap file. Now, I could create, for data exchange purposes, my own set of rules to exchange, like the example I gave last time, information between libraries, let's say, interlibrary loans. I might exchange data in an XML file that I made up, all right? And as long as everyone that's getting that file knows the rules for it, then they can process it, all right? So it's extensible in the fact that you can create it for many things. HTML is a language to develop web pages. XML is a language where you can develop your own formats for your own purposes. But once you've developed those rules have to be followed. They can't be extended without everyone knowing about it and everyone doing it. So let me go and open up where we left off last time. And go from there. And let's talk about what is important about the XML, both in terms of what's important for it to both in terms of what's important for it in terms of achieving the sitemap, but in terms of what's important of it in just XML terms. So I'm going to go and open this. We have all our master pages from last time, which is good. It would be good practice for you in all future assignments to use a master page, just to get used to that, all right? Because some of the assignments are small, some of the assignments that you'll have will be bigger, some are small. Your most recent assignment, I think you have to develop a site that has a handful of pages, so you definitely would want to use a master page for that. But even going forward, as we develop little assignments, use a master page just to practice it, and use the navigation controls. It's kind of funny sometimes, and I guess maybe it's my fault for not making expectations clear, but we study something in class and we have an assignment for it, and then people do it on that assignment, all right? So they get that idea that, gee, the next assignment you should have a master page. But then, from there on in, they forget that there's such a thing as master pages, because we're done with that unit. All right, we're done talking about master pages, therefore the next assignment they're not going to do it for. Well, it's a good idea to go back and practice this, because you're not going to be, not that master pages are that hard, or that any of these concepts individually are that hard, but you're not necessarily going to really know it after doing it just one time. It's good to go back and practice the stuff that you've done before. That's like if you've taken the web development class and you know HTML and CSS. Again, this class doesn't focus on that, but consider it a good opportunity to practice it. And again, doesn't have to be elaborate. With just a handful of CSS things, you can really make your page a notch better than it would be if you just did no formatting whatsoever. All right. So let's go and open it. And if you remember, we had a master page where we actually put two navigations on it, not because you need two navigations, but just to illustrate the menu control versus a tree view control. All right, so here's our tree view control, here's our menu control. The menu control was hard-coded. We could also bind that to the sitemap data, and we'll probably do that at some point. Also bound to the sitemap data is my breadcrumbs, known in ASP.NET as a sitemap path. I can never remember what it's known as in ASP.NET, so I always call it breadcrumbs, because that's sort of the term that I've heard before. I'm sure that probably comes from the old Hansel and Gretel story, where the kids are walking through the woods, and to know how to get back home, they drop breadcrumbs along the way so that they could follow them back home, so they wouldn't get lost. All right. I really wonder how many, do people tell their kids those stories these days anymore? I don't know. I mean, I heard it when I was a kid. I really wonder, in the future, are there going to be things that just aren't going to make sense to people? Like dialing a phone. You don't really dial a phone. You press buttons on it, but people still call it dialing a phone. And there's a few other things like that that sort of are old-fashioned words. You never know the pain of dialing a phone number on a dial rotary phone that has a lot of nines in it, right? Because it takes longer to call it because the dial has to spin around, and your finger liable to slip, and you get 6 of the numbers in, and finger slips, and you have to dial it all over again. All the struggles that kids these days don't have to partake in. All right. what is data binding? Data binding is where you have the source of the data in one place, and you have the visual representation of it in another place, in another control. And you sort of marry those two together. So you have a data source that provides the data to fill up something visual on the screen. In this case, the data source is a sitemap data source. That is going to read my sitemap XML file, which I've created over here, web.sitemap. All right. Both the tree view and the breadcrumbs use that. So that already hints at the advantage of the sitemap file. I only have to get it right once. I only have to get it right in the sitemap XML file, and both of these will automatically be updated. All right, and they'll automatically be consistent. So it's not like I have it hard-coded in both of them, where if I change it in one, I also have to go back and change it in another. And again, I can't emphasize enough how this is a common thread throughout all software, web, mobile development. Not repeating yourself, not writing code or data, putting it in more than one place. Later on today in class, probably, we're going to talk about databases. And we're going to talk about the rules for database normalization. And honestly, for the most part, the rules of database normalization can be summarized by saying, you know, only have the data, only have a piece of data stored in one place. All right, because if you're breaking the rules of database normalization, what you really have is you have pieces of data that are stored in different places. All right, and what's wrong with that? Well, consistency. If my phone number is stored in two places in a database, if I change my phone number, then it has to be changed in two places. Well, what if I mess up? Or what if they mess up and they only change it in one place? Well, then they have bad data. All right? Yes?
Well, doesn't it depend on what table your phone number is in and what's connected to that table? Because let's say that you have, well, table might be the wrong word to use, but let's say that you are in one group that's called teachers.
Yes.
And then under that group, you have all your students.
Yes.
So if you change your number wrong, well then all the students will then see the wrong number, right? So it all depends where you change and what's connected to it, right?
Well, yeah, but the good news is if I change it in that one place, then all the students will see the right number.
Yeah.
All right. So there's nothing you can do to guarantee accuracy, right? I mean, if someone misspells the name Mike, they've misspelled the name Mike. You know, there's nothing we can do to keep that from happening. But the idea is if something either changes or if there's an error to be fixed, all right, you don't have to go in several places. So the opposite of that would be if I had to go in for every student and change my phone number. That would be bad. Right? Because what's going to happen? Well, you're liable to miss a student, and they're going to have the wrong phone number. Whereas if you only have to change it in one place, and so the design of the tables that you come up with can be well designed, and by well designed it means that the data is all in one place. All right? Doesn't mean that the data isn't shared between multiple places. It means that the data is stored in one place. All right. So at any rate, our sitemap could be incorrect or it could be right, but both the control for the breadcrumbs and the tree control use the same place. And so if we add things, that's okay. They'll immediately be reflected in both, as opposed to being reflected up here in the menu where I hard-coded that data in. In fact, I'm going to delete, for this example, I'm going to go and delete the menu control. Simply because that's a little confusing to have two navigations. If anyone wants to see both navigations, they can see the earlier example. All right. Now, where is our sitemap? This is the XML file. Now remember what I said before about just because it's extensible doesn't mean I can do anything. Alright? There's only 2 tags which are allowed in the sitemap XML file. One is the sitemap tag. Alright? And here's where I think I misspoke. I think I misspoke when I said that tags had to be all lowercase. That's not true, because these tags are not all lowercase. I think I was getting confused with something else. So never mind that statement. But one of the tags that you have is the sitemap tag. That is a root tag. You only have one of these per sitemap XML file. Only one. That's a rule of XML, is that every XML file has one root tag that everything else is part of. That would be like the HTML tag in an HTML file, right? There's only one HTML tag. You could have many links, you could have many paragraphs, you can have many sections, but there's only one HTML tag, and everything is contained as part of that HTML tag. Well, the rule for here is, with the sitemap XML file, there's one sitemap tag. We're going to talk about a couple of things. We're not going to spend tons of time on this, but I do want to mention them. This line up here is sort of like the doc type in HTML. It specifies as what version of the XML language we're using and what our character encoding is. UTF-8 is for like the standard, I think it's called Roman alphabet, and you would use it for that. If you were doing something for some international context, you might use another character set. If you wanted to have things like accents and other characters that aren't in the standard alphabet. So that's like the doc type. Version of XML and encoding. You might say there's no ending tag for this. Well, this isn't a tag. This is called a declaration. You can tell it's a declaration because it starts with a question mark. Alright? So that, strictly speaking, is not a tag. That's a declaration. And therefore it's not limited to the rules of tags, which say that every starting tag has to have an ending tag. The sitemap tag has an attribute called XML NS. And that stands for XML Namespace. Alright? XML Namespace. That is a definition. That is a definition of the rules that this XML file follows. And typically you use a URL to do that. Why do you use a URL? You use a URL because URLs are unique, right? There are not two pages or two sites on the internet named schemas.microsoft.com/asp.net/sitemapfile 1.0. Keep in mind that this may actually point to a web page, but it really doesn't need to. It's not as though it's running out to the web to find that. This is just for identification purposes. Let me give you an example of how this could be used and how it would be used. So the namespace identifies sort of the kind of rules that are going to be followed. Let's say I am doing an application for Cedar Point, the amusement park. That was a big park, right? There's a lot of attractions, and there's a lot of things, and they have a map of the site, right? That says where this roller coaster is, and where the restrooms are, and where the places to eat are, and so forth. They have a map of that site, all right? I could make a site map. If I was working on an application for Cedar Point, I might make an XML file that was my site map, that coincidentally is the same name as Microsoft's sitemap. Well, there needs to be some way to distinguish whose sitemap are you talking about. Are you talking about the sitemap that Microsoft developed for ASP.NET websites? Or are you talking about the sitemap that your Cedar Point application is using to record sites to record a map of the sites that are on the park. All right, so they both could be called sitemaps. All right, the namespace would let the program know what kind of sitemap we're talking about. So we're talking about the one that is defined by Microsoft, not anyone else's sitemap. So I'm going to copy this just for curiosity. I'm going to see what that web page corresponds to. And as predicted, it doesn't correspond to a page. Well, I guess I didn't really predict it. I suggested that that was a possibility. All right. So, all that does, the reason they use the URL convention for naming the namespace is just that there aren't two companies who use the URL of Microsoft.com. All right? There's only one. And as long as they make sure that that's unique, as long as Microsoft only uses that URL, then everything will be okay. All right. So that's the rules so far of a sitemap. The second rule is underneath the sitemap, there has to be a main sitemap node. So I can't do this. Gives me a blue squiggly line. What that means is I'm violating the schema. It would be sort of like putting in an invalid HTML tag. Maybe you've been typing in HTML in Visual Studio and you forget that you forget that the tag for navigation is nav, and you type in the full word navigation. You'll get a similar blue squiggly line telling you, hey, we don't know what kind of tag that is. Or, some student had this problem a couple days ago in lab, where they put something in the head section that belonged in the body section. And they got a little squiggly line saying, hey, an H1 doesn't belong in the head section, it belongs in the body section. Well, what this is saying is, if you read this closely, the element sitemap has an invalid child element sitemap node in namespace. It's not a terribly clear explanation of what the problem is. And the problem is this, that every sitemap directly underneath the sitemap XML has to have one and only one sitemap node. And that, of course, is going to correspond to the home page, right? That's your starting point of everything, is your home page. Now, you might wonder, well, look, what's the difference of what I had a minute ago and what I have now? The difference is all of these sitemap nodes are included within the main sitemap node. So I can only have a single main sitemap node within my sitemap XML, and any other ones have to be included in that. After that, it's fair game. So I can nest things if I want. I can put as many nodes as there are pages underneath this main node, but there can only be one main sitemap node, and every other sitemap node is under that. So again, it's extensible, but that doesn't mean I get to do whatever I want. I have to follow the rules that were defined by whoever created this format. And I also can't just create tags for the heck of it. Again, I get the blue squiggly line. There's no such thing as an A tag in this particular kind of file. Now, the one other thing that's similar to HTML is if you notice this sitemap node tag, it's a starting tag, but it ends with the / greater than sign. What that means is that this is a start node and end node rolled into one. This is a starting tag and an ending tag rolled into one. The alternative to that would be this. Where I write the sitemap node, starting tag and an ending tag with nothing inside it. With nothing between the starting and ending sitemap node tag, though, it's pretty useless. That's called an empty tag because there's nothing between the starting and ending tag. So usually what we do is this. And we'll put the / here. Now, notice we had two different kinds of errors. We had the blue squiggly and the red squiggly. The blue squiggly represents something that's wrong for this particular XML file. In other words, if I try to put an A tag here, I get a blue squiggly. Why? Because A's are illegal in this kind of XML file. If I were to eliminate this tag, I'm going to get a red squiggly. I'm actually getting two red squigglies. The reason for that is I have just violated the rules of XML. What I have here would not be valid for any XML file because I have a starting tag without an ending tag. And therefore it's going to complain that this tag doesn't have a closing tag. And this tag can't be here because we need the ending tag. So red squigglies indicate that you violated the rules of XML. Blue squigglies indicate that you violated the rules for that particular kind of XML file. So if I want a hierarchy like I had before, remember that I had locations, then I had products, then I had cheese and cookies, then under cheese I had American and Swiss. I would achieve that by nesting. All right? So I could do something like this. I could say products then between that, I could have a sitemap node for cheese. And a sitemap node for cookies. Now cookies, in our example, there was only one cookies page, if I remember right. So there's nothing contained in the cookies section. Therefore, I could make this an empty tag. This could be a starting and ending tag on its own. For products, though, I'm going to have stuff in between it because there's stuff in our hierarchy that exists underneath products. Remember, we had a cheese and then a, oh, my mistake. This should be, actually this is a cheese section. Under products, we have cheese and cookies, so this should be cheese. Now, I can omit the URL if there's not actually a page associated with it. In other words, if it's just used to group things together. So I may not have a generic cheese page. I may have a page for Swiss cheese and a page for American cheese. But not a page that's a generic page for cheese. If I do, I could put the URL there. If I don't have a generic cheese page, I can omit the URL, and it will just appear as sort of like a grouping layer, a grouping level. So I'll go and I'll add this. For Swiss and American. All right. Now, I don't have any blue or red squigglies, which indicates that this syntactically should be correct. All right. Last time, I created my sitemap source, and I married the sitemap source to these two things, my menu control and my breadcrumbs. So now I go and start debugging. And you'll notice when it finally decides to come up, you'll notice that the tree view matches the structure of the XML file. In other words, the way things are nested in my XML file, they'll be nested in my tree view. So I click on, I expand home. I must have called that location. All right. That should be products. I'll go back and change that. And I can expand cheese to show Swiss and American. Why isn't cheese blue and big like that? Well, because if you remember, cheese was just a grouping element. There was no URL associated with it. Therefore, there is no link for it. It's just there for me to group things together. Let me go back and change. My sitemap. Notice the description of products actually said location. So I'm going to go in, I'm going to make a cheese, or make a Swiss cheese page by going to New File. I'm going to make a web form. I'm going to call it Swiss. I want to select code from a master page. I have two. I'll select this one. And I'll put in here that this is my Swiss cheese page. So now if I go and run this, I'll set the default page to my starting page. If I go and run this, if I go and navigate to the Swiss cheese page, notice it shows the path of how I got there. I went from home to products to cheese to Swiss. And there I am on my Swiss cheese page. If I go somewhere else, to my location page, it shows I went from home to location. That again is a valuable navigational tool. And the good news is we can build a tree view, or we can build a menu view and bind it to the same sitemap XML file as we bind our sitemap path control. So it will keep it consistent. So all I have to do is change it in one place, and the change is reflected both in the navigation and in the breadcrumbs. So to summarize, what does ASP.NET do for your UI in terms of reusability? Very important thing it does is it allows you to create master pages. All right, and you can even nest master pages if you have certain sections of your site that have common content in them. All right. There are two navigation controls. There is a menu and there is a tree view, and they each have their respective advantages and disadvantages. They all have their similar behavior. These can be bound to a sitemap to a sitemap XML file that contains information about what pages are available on the site, so that if you need to add a page, you simply add it to the sitemap file and you're good to go. Also, breadcrumbs can be bound to the same thing, and by both binding that data to the same place, you're going to guarantee a consistency between the two places. The notion of binding is really important. Again, the notion of having a place where the data comes from and a place where you display the data is very important. And we're going to continue to explore that as we go forward. We're going to do a lot with data binding when you come to databases. All right? For example, you may retrieve all the departments that a company has from the database. So you do a SQL statement to grab the departments that exist in the company's database. You could display that information a couple different ways. You could display a table that shows all of the departments within that company. You could put those departments in a drop-down menu to allow the user to select which department they want to see. You could display a list of them in a table, like I mentioned a minute ago. You could display a form view where you had a form for each department that they could page through. So a page would show the first form. They click the next button, they see the next department, they see the next department, and so on. That's a key point, and this binding allows you to do that. The fact that you can take data, and once you define a data source, you can choose to display that data source a variety of different ways. So we're separating the retrieving of the data from the way that we're going to display it. It's one of those things that just makes good sense from a programming perspective. You're separating where the data comes from how you're going to display it. Because you might want to display it a couple different ways, and this will allow you to do that. Any questions on this? All right. Our next topic is a big one, and we're going to spend a little bit of time reviewing it. And my plan is to do this, to review concepts in database, and then show how you do those, how you actually can implement databases in ASP.NET. So we'll sort of go back and forth between the two. We'll talk about some basic database concepts, then we'll do some basic database stuff in ASP.NET. We'll talk about more involved database concepts, and we'll then do more advanced stuff in ASP.NET and so on. So we're going to run through these things sort of in parallel. But the first is the review. How many of you have had CISS243, the database class?
I'm taking it right now.
Taking it right now. Okay. It's one of those things, again, that maybe you've had it, maybe you're taking it right now. But if you haven't used it, then some of the concepts might not be clear to you anymore. So let's do CISS, let's do the first couple weeks of CISS243 in 25 minutes. All right, give or take. What is a database?
Place to store data.
Place to store data. All right? That certainly is a true statement.
Massive amount of data.
Okay. Place to store data. Let me think of a way to put that. You can store massive amounts. You don't have to, all right, but you can. So I'll put that as capable of a large volume of data. I mean, that's not an absolute requirement. You can have smaller databases if you're working on a smaller project. Is a collection of Excel documents a database?
It could be.
It could be. It's a collection of just files where, well, let me put it this way. It's a collection of files where you, let's say you open up a bunch of files in Notepad and make text files. All right? And in one you put the list of all your friends. In another you put the list of all the businesses that you deal with. In another you put the list of warranties you have on your products. And so on down the line. Is that a database?
Yeah, it is. Yeah.
Informally, we might call it a database. But just like Excel files, we could call that a database, but typically not. Because when we talk about databases, at least when I talk about databases, I'm talking about a specific sort of databases. And that is a relational database. So I suppose you could call any collection of data a database. But really what we're interested in is a relational database. Now what is the additional requirement that a relational database has that these other sorts of forms of storing data doesn't have?
You have to have a primary key.
Okay, you do have to have a primary key. That is true.
Like you have to put everything into boxes. Is the best way I can say it.
Put everything into boxes.
Like so they have a relation to each other.
Exactly. The word itself, relational database, implies a difference. That we're not just storing data, we're storing data and relationships between data. So think of my text files, where I have a list of the people that I know. All right? And maybe one of the people I know is Anne. a mechanic at Tuffy Muffler. All right? So, I might have a list of the companies I deal with, and I can find Tuffy Muffler's number. That list is sort of a silo, though. In my hypothetical collection of text files, I don't have anything that links Ann to Tuffy. All right? Now you might say, well, I could put in my list of contacts, I could put the fact that Ann worked at Tuffy, and here's the phone number at Tuffy. And then I have in the company table, I have Tuffy, their phone number, and the person I've dealt with there is Ann, and here is her email address. I could do that. But what's the problem of doing that? If I put in my text file for companies, I put information about a contact, and if in my contact file I put information about a company. What's the problem with that? So if I did something like this, and again, these could be spreadsheets, these could be text files, but in my company one, I have Tuffy Muffler, phone number is 440-555-1212. My contact there is Ann, whose email address is ann@tuffy.com. Then I can have a separate contact file. And I could say that Ann, whose email is ann@tuffy.com, and Ann works at Tuffy Muffler, and here's the phone number. It's what kind of data?
Redundant.
It's redundant data. Whoa. What do we mean by redundant data? What's another way of saying redundant data? Duplicate data. Duplicate data that doesn't add value, all right, and in fact it creates problems. All right? When I talk about redundant data, I don't mean like duplicating the data like making a backup of your data files. That's duplicating your data literally. That's not what I mean. When I talk about redundant data or duplicate data, I'm talking about I have the same piece of data in more than one place. All right? And it doesn't add any value. All right? Now, in this case, what are the problems associated with this? Well, go ahead.
If you're going to change one place, you got to make sure you change the other place.
Exactly. If you change a piece of data in one place, you got to make sure you change it in another place. So let's say that Ann gets a new email address because of, some corporate policy change. And it becomes AnnSmith@tuffy.com. I'd have to change it here. And I'd have to change it here. Now what's the problem with that? Consistency, right? You're liable to make a mistake and not change it in both places.
That was what I was trying to explain before.
Okay.
That what we're doing right now.
Okay. But again, this is not with a relational database. So within a relational database, you wouldn't have it designed like this. So you wouldn't run into this sort of issue. All right? So this is a problem that we have if we're not using a relational database. Or, actually, I guess we could have this problem if we're using a relational database, but we don't do it properly. All right? Because again, everything's going to be okay, and that you're going to not have, redundant data. Databases provide you tools to allow you to design a database without redundancies, but they still have, those tools have to be used correctly. All right? So, a big notion of a relational database is that a single piece of data is only stored in one place. So, what would a single piece of data be? A single piece of data might be, for example, that Ann's email address is ann@tuffy.com. That's a single piece of data. In a relational database that's been designed correctly, that single piece of data will only be stored once. The fact that Ann works at Tuffy would only be stored in one place. So that relationship between a company and a contact would only be stored in one place. Now, could there also be another person that works for Tuffy? Sure. So George could work at Tuffy as well. Well, that single piece of information that George works at Tuffy should also only be stored in one place. So that's the key of databases. Relational removes redundancy, so no redundant data. That's our goal in designing it. So, couple pieces of terminology. What is a table?
Table is where you have all your information that you want to put in the table.
Repeat that, please.
Table is where you have all your information like name, phone number, stuff like that you want to store in there.
All of your information?
Some of it.
Okay. Well, what information do you have in there? You gave a good example.
We'll
Name.
put name, phone number, email, address.
Name, phone number, email, address for what?
Well, first of all, we need to make an overall table name for whatever we want to put in the table, right? So
Okay.
Tuffy's muffler, and then you want to put the people in there, right?
Okay. Would Tuffy Muffler be a table? Let's think through this example. Would Tuffy Muffler be a table? What? Probably not. No. Why wouldn't Tuffy be a table? Well, because what if I started doing business with another company? Maybe I used a body shop to fix, to make body repairs to my car. You don't want to have to create a new table, all right? Just because you're adding data to the equation. Yes. Okay. What would Tuffy and Joe's Auto Body and other companies I deal with, Verizon and so on. Would I want to put all those in one table?
If it's just company information.
Right. What I'm getting at is, I think you're on the right track, but I think you're missing a point. And I think you attempted to do it by saying you'd have a table for stuff about Tuffy. You'd have a company table where you would have information about all the companies that you deal with. So a table is all the data about one entity. And what do I mean by entity? When I use the word entity, what do I mean? All right, it's going to turn into an English class. All right? What part of speech are entities? Entities are typically nouns. What are nouns? Nouns are person, place, and things. All right? So, one entity, and going back to my hypothetical situation, one of my entities would be company, and one of my entities would be contacts. All right? One entity is company, one entity is contact. If you're doing database design, listen to the people that you talk to, because typically if you're doing database design, you'll talk to someone from that organization, and they'll tell you about how their business works. Or if I was doing a database for myself, I would think about like, well, what kind of data? Well, I have a list of companies that I deal with. For these companies, I have the employees that I specifically have dealt with. All right, these are my contacts at these companies. All right. Not 100%, but oftentimes if you pluck the nouns out of those statements, those are going to be your tables. So companies, contacts are the nouns in those statements that I have. Usually the nouns are either going to be tables, attributes, or relationships. So in this case, company and contact are going to be my entities. So in the table, we're going to start all the data, fields, columns, pieces of data.
Could you put services under as an entity as well?
How's a service different than a company?
Let's say you deal with two people from the same company, will they do two different things?
I could expand it to do that. That might be in the contact file though, right?
Okay.
Because maybe I go to Tuffy Muffler, I see George for my tune-ups, and I see Ann for my exhaust system problems. And I could do something like that. Absolutely. All right.
Maybe I'm thinking too abstract, I don't know.
No, I mean, we could clearly build this as big as we needed to, or as neat as we want to. I want to keep the initial example, though, fairly straightforward, and we'll just talk about these two entities, because I think we can talk about most of the things that I want to talk about today by just talking about these two entities. When we get into when we get into bigger database design issues, then we can bring some more entities into the picture. All right. What do we call each piece of data about an entity? I think I've already used like 3 words to describe that. What do I call a single piece of data about an entity?
Is it an attribute?
An attribute is one way to put it. What's another way to put it? Sometimes a field, sometimes a column. All those things mean the same thing. So, what would be the fields that we would have about company? Name. What else? Address. Phone number. And maybe we have more information, but we'll stick with this. What information would I have about contacts? Okay, probably some of the same sort of stuff. Name. Maybe phone. Maybe email. All right. Now, so far we're not really any better off than we were with our separate files, where we had a contact file and we had a company file, because there's no way to link these two things together. Remember, with a relational database, rows, or members of each table, are related. How are they related? How could I relate the company to the contact? How would I show that Ann works at Tuffy, and John works at Time Warner, and Pete works at Verizon? How do I show that?
Primary key and foreign key.
Primary key and foreign key. Excellent. What is a primary key?
Unique attribute.
Yeah, it's something that is unique. What does the word unique mean? I mean, people will say sometimes like, I have a unique problem.
Special.
All right? It actually means more than special. All right? In conversation, people use the word unique to mean special. But unique really means something a little more than just special. One of a kind. There is only one. So if I say I have a unique problem, it's the day before payday and I'm broke. All right? Is that a unique problem? No. A lot of people experience that problem. All right? So it's not a unique problem. Now, if I were to say, let's see. I have a unique problem. My contract for here at Lorain Community College for teaching CISS243 has the wrong date on it. Yeah, that's probably a unique problem. There's no one else in the world that probably has that problem. All right? So that's really what we mean by unique. All right? Now, with that in mind, what would we use as a primary key? So it has to be unique. Another thing about a primary key is you have to have it. All right? You have to have it. So, for example, some of these things might be optional. Like, maybe I don't know the address of Amazon, for example. All right? I'm sure Amazon has an address, but maybe I don't know it. Or some of these other attributes might be optional. Primary key has to be required. You can't have something in there. All right? What might be a good choice for primary key of company? Might be name, but I'll tell you, a lot of times we don't use names as primary keys. Why not? There is a possibility that there could be two companies that have the same name. For example, for the longest time, and I hope I'm getting my names right, for the longest time there was an Angelo's Pizza in Amherst and there's an Angelo's Pizza like in Lakewood or something. So if I had Angelo's Pizza as a company name, that would be duplicated. And again, it's not unique, because unique means literally there's only one instance of that value. The other problem with this is letters and things like names are going to take up a lot of space to store. And when we talk about creating relationships and foreign keys, that could be a problem if we had to store for every person a 30-character name of the company that they worked for. So, if name isn't good, what could we use instead?
Auto numbers.
We could use an auto number, all right? And we'll talk about auto numbers in a second, but I can make up some sort of ID number. All right? An auto number simply means that the first company you entered gets a value of 1. The second company gets a value of 2. The third company gets a value of 3. And so on down the line. It's sometimes called a surrogate key because it doesn't really mean anything. In other words, if I entered Tuffy first, it gets 1. If I enter Time Warner second, it'll get a 2. If I flip those around, nothing really changes. Then Time Warner's 1 and Tuffy's 2. But really, it's arbitrary what order I enter them in, and it's arbitrary what number gets assigned to it. But we will guarantee it's unique. Yes?
Is it comparable to saying that something have a certain spot in memory, like when you give them that ID number? Because company, let's say company's muffler, if that gets
it's stored, the analogy is true in the sense that you'll be able to use that number to retrieve that information. Just like if you can use a memory location to pull out a piece of something that was stored in memory. So in that case, the analogy is true. So we're going to put a company ID here. What about contacts? Well, contacts, again, we can't use name really because there could be two people that have the same name. So, therefore, we're going to use a contact ID. So now, and again, it can be an auto number, so we just generate a number, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's really not an issue if you delete someone, it just skips that number from there on in. All right? So there might not be a contact number 9 if you no longer are doing business with that person. All right? But that's okay, you're not going to run out of numbers. Numbers are stored more efficiently than letters are, by the way. So that sort of cuts down a little bit on the space, especially when we start talking about relationships. Now, okay, so we have a primary key, but we need to do one more thing to achieve the relationship between the contact entity and the company entity. And what is that? And you alluded to it a minute ago when you said a foreign key. Go ahead. A foreign key. And what would that foreign key look like, specifically?
Just like primary key?
Pardon me?
Just like primary key?
Well, it's similar to a primary key, but what would we add to which table to make this work?
Company ID to a contact.
We would add a company ID to a contact. Usually, I'll put a single asterisk next to the primary key, and I'll put a double asterisk next to a foreign key. So, foreign key in one table points to a primary key of another table. That's why the primary key has to be unique, right? If there were two company number 1s, and I said Ann worked for company number 1, all right, then I wouldn't know, do they work for the first number 1 or the second number 1? And it would be kind of useless. If it's unique then, I know, well, Ann works for company number 1, all right? And if I need any information about company number 1, like what the address is, I can use the ID here to look up that company and grab the address. So every piece of information now is only stored in one place. The ID of the company, the name of the company, the address, the phone number, the contact ID, the name, the phone, the email. The company ID. Now you might say, well, company ID, that's in two places. This means something else. This is the company ID for that particular contact. So this is where Ann works. This is where George works. This is where Pete works. So this really isn't duplicated data. On each element of this table, it is the company ID that that particular contact works for. And now we have a relationship between those two. A foreign key does one step better, all right? It guarantees that if there's a foreign key between these two, that you can't put in a person that doesn't match up with a company, all right? So, let's say I have companies 1 through 100, all right? I could not put in that Al worked for company 200, all right? The database simply won't allow me to do that. That is what's known as referential integrity. Are there any questions about this? We'll pick up on this on Tuesday. We'll do a little bit more about database concepts to just make sure everyone's on the same page and to review it or possibly introduce you to some of these concepts. And then I'll come back and we'll actually start to show how you can do this stuff, retrieve data on ASP.NET pages.